So in this video, we are going to speak about some of the analysis types, namely the OT analysis and TT analysis and how they work. Um, as we know, analysis type should be chosen in a way to best match the requirements of a circuit. So we are going to see the various properties of and the features of OT analysis and TT analysis in this video. So OT analysis refers to one-time analysis, and the circuit is simulated with predefined node values till the bias point is reached. That is, till the simulation reaches a stable point, the simulation continues and then ends. So the initial node voltages can be set up by using fixed voltage, scan, and main security setup construct, and it does not take any argument, as you can see in the syntax, that it's end main security OT analysis, and there is no argument after this. It does not like plot and clock cannot be used with OT analysis, and is generally useful for combinational circuits. Um, okay, so that's all for OT analysis. Now let us see what is TT analysis. So TT analysis refers to truth table analysis. As we know, the truth table is a combination of all possible input values giving particular output values. So similarly, TT analysis performs OT analysis with every possible combination of input values if an input file is not provided. The input node names need to be provided as arguments to TT analysis. Now we can also provide an input file as an argument to TT analysis, in which case TT analysis is carried out only for specified combination of node voltages as provided in the file. Also, we can set specified voltage combinations to the input values at specified time values by providing the time data. So, if we provide the time data, we can specify the voltages at those points. Like we can use a custom time voltage relationship. Like I can specify the voltages at a particular time. Um, if I use the input file having time value. The plot can be used with TT analysis only when time data is provided in the input file. This is obvious because as you see that plot, anything that is plotted is basically a voltage time relationship. So if we don't have the time data, then it cannot be plotted. And it does not support a scan and clock, and generally used for combination circuits, and this is the syntax. As you can see, it takes input node values as its argument, and the file name with its extension .txt and colon time. This is how we write it. This is an optional argument, and similarly the entire thing can be written anywhere in the argument list, and that is optional as well. So the input file as well as the time to the argument is optional. If the input file is provided without the time, then the voltage values of the for the input nodes are to be provided in the same way as in the main circuit setup construct. So if time is used, then the time values are to be written as the first value in each row of the data value, just like main circuit setup input files. So yeah, so whenever we are using an input file and we are using a time argument, then the time values have to be written as the first value in each row in the input file. That is, the first column should contain all the time values in milliseconds. So this is a figure which is showing TT analysis, and we'll see a demo program which we have written, and so let us see that. I have opened the CMD font already. So yeah, SIT. So let us see what I have written. What have I written? So this is a circuit which is showing OT analysis and TT analysis. So this is a subcircuit 3 input XOR, which has 3 input nodes 0, 1, 2 and an output node 3. So we are performing. First, let us see how does OT analysis work, which is one-time analysis. That is, the circuit is simulated till we reach a stable state condition. So what are we doing? We are scanning and printing the node values, specified node values. So we are using OT analysis, right? This is the syntax. Okay, so let's run it and see. So as you know, XOR is a odd and even parity checker. So whenever we have odd number of ones, it will lead to 1, and whenever there is an even number of 1, it will lead to zeros. So if we give ones in all three of its inputs, then the output is 1. Uh, so so it basically, I'm sorry. Um, so it basically scans the nodes and prints them, and this gives us the simulation time. Okay. So that's OT analysis.